Assalamualaikum warahmatullahi wabarakatuh. Welcome back to my channel, everyone. Today, in this video, I will continue. This is part 2 about static fluid. I will continue our discussion. If you are first time to see this video, I suggest you to see my first video, the part 1, because this is the continue from part 1. Before we start the explanations, you can subscribe my channel and then turn on the notification to update other videos from me. Okay, let's start our discussion about static fluid, and then we start part 2 with hydraulic lever. I am still using this book here, book of Zambak. Hydraulic lever we read together because in this paragraph gives many important things to us. We read together. The hydraulic lever takes advantage of Pascal's principle to lift heavy objects with a small force. The working principle is to apply the same pressure over different areas. This is very important. Figure 1.15. The pressures at point A and B must be equal because both points are at the same level. Remember, the pressure in a stationary liquid is the same at all points of the same depth. Okay, so in this case we are trying to take the advantage of Pascal principle, where we are trying to the advantage of Pascal principle. In this case, we try to lift the heavy object. The heavy object here is a car. The car. We have WC for the weight of the car, and then we are trying to lift this car using only the weight of human. Weight of human. And then how could it be if we want to lift the car that this one as a heavy object, but we only using the weight from human? We can use the principle of Pascal. How we get same pressures but different forces, so the area here should be different. Should be different. Why? Because the pressure equal to force over area. If the force big, you can use the area also big. If your force small, the area also small, and then it can give same pressure. So you can lift the weight of heavy object using light object when you change the area also. When you change the area for heavy object using a bigger area, and then for the light object using smaller area, and then it can give same pressure. And then for a static liquid, the pressure at point where those points are same level, the pressure are equal. The characteristic were same level. So in here, P A equal to PB, but in this case using 1 and 2, no problem. And PB F1 over A1 equal to F2 over A2. So we can lift the heavy object using a light object, and then you can find this phenomena when you are in car wash. In car wash, if you ever seen, there is a cylinder, very big cylinder to raise the car, and then using only if you ever seen how the person at there raise or lift the car only using open faucet. The open faucet, there is fluid inside. The faucet you ever seen very small. Very small. So to raise the car only needs very small force, because the area of faucet are very small. Okay, and then the area of cylinder that lift the car is big, but the area of the faucet is small. Okay, how pressure measurements, how to measure the pressure. In here we can use from this book using mercury barometer, and then the founder is Torricelli. At that time, Torricelli using these equipments to measure, and then he also found the unit of pressure, other unit of pressure. Yeah. Okay, there is a container, a cylinder container, and then containing mercury, and then there is a long glass tube above it, and then when long glass tube put like that, and then the mercury inside the container move up until certain height, give symbol H like that, and then here become vacuum, and then also the Torricelli is the first founder of a vacuum condition on Earth. There is pressure from atmosphere P0, and then based on pressure and its relation with depth, the location or the points where the depth is equal, the pressure is equal. Yeah, if we focus on 2 points here, A and B here, if you see A and B at the same depth, same level, so PA and PB are equal. Okay, at the point A, remember, if we talk about pressure, we talk about object or something above it. Yeah, above point A there is atmosphere, so above point A, the pressure at A because of the atmospheric pressure P0, and then above the PB there is pressure from mercury inside the glass tube. So at the point B, the pressure comes from pressure from mercury. Yeah, this mercury, not all the mercury, but mercury above the point B. Torricelli said that the atmospheric pressure will approximately equal to the height of mercury in the column. Yeah, and then at that time when the Torricelli he measured the atmospheric pressure at 180 m. He said like that, and then the mercury move up inside the long glass tube until the height of 76 centimeter. 76 centimeter. 180 m to be equivalent to the 76 centimeter SG. Yeah, 180 m equal to 76 centimeter HG. Yeah, this is where it's come from. 180 m is equal to 76 centimeter HG. Okay, and then if you try to submit the numbers for every part for the PHG, the rho Hg times G times H. Yeah, this is a static fluid. The rho of mercury, this one the gravitational acceleration on Earth, and then this one the height of mercury, 76 centimeter or 0.76 meter. And then you got the pressure, this complicated number, 101,325 Pascal. Yeah, 25 Pascal, and then we round it become 100,000 Pascal. This is where it come from. 180 m is equal to 76 centimeter Hg equal to 10 power 5 Pascal. This is where it's come from, this unit, and then the Torricelli found these units. Yeah, this is by Torricelli. Okay. And then how we measure the pressure, the second equipment is the open tube manometer. The open tube manometer shown in figure 1.17. Yeah, it is used to measure pressure of gas trapped in a closed container. Yeah, this one the closed container, and then there is gas inside, and then we are going to use these equipments to find out the pressure of the gas inside it. And the fluid inside is a mercury Sg, and then when you see there is different height of mercury, right? At the point A here, this is the border, yeah, between gas and mercury. And then if you see the other side, the height of mercury, this one the peak, different in height. Yeah, there is symbol H. This one the differences of the height of mercury in the tube. How to measure the pressure of the gas? Still the same, using the correlation between pressure and depth. Yeah, the location where the depth or level same, the pressure is the same. Okay, and then we put 2 points right here, point A and point B. The point A located at the border, and then we use dash line like that, and then we find the point B. The point B has same level with point A, and then we can write at the same level PA equal to PB. Okay, and then above A is a P gas, and then above B there is P from mercury, this height, yeah, and then pressure from atmosphere, there is P0. Above point P there is pressure from mercury and then pressure from atmosphere, yeah, P0 plus PHG. Okay, and then we replace PA P gas, and then PB is a P0 plus P rho GH. From this formula, P gas is equal to P0 plus rho GH. Where is absolute pressure? Absolute pressure is the P of gas, yeah, and then P atmospheric pressure, this one, and then rho GH as the gauge pressure. This one, the gauge pressure. So gauge pressure is the pressure from the fluid, yeah, from the fluid inside the object. This one, the gauge pressure. Okay, if absolute pressure, we can learn gauge pressure plus the atmospheric, and then we call this one as absolute pressure. This one atmospheric, this one gauge pressure. For the YouTube shown in figure 1.18, the pressure at point A and B are equal. Since both arms are open to atmospheric pressure, it cancels out of both sides of the equations, thus the equation become like this. So actually there is P0 right here and P0 right here, and then we can cancel both of them, yeah, because at the left and right side. Okay, and then PA and PV. This one, the other important thing, the pressure at the same level is equal. This works only for location with same fluid, yeah. A and B located at the same tap and same liquid. If you put here this one is not same pressure, yeah, because the pressure because the point located at different fluids, yeah, different fluids. If the same fluids at the same level, same pressure. If different fluids even in the same level, both of them different pressure. Okay, above point A, rho 3 GH3, above point B, rho 1 GH1 plus rho 2 GH2. Okay, right now let's start to solve some problem regarding to the static fluids, especially the density and pressure, yeah, fluid pressure. Okay, number one, what is the mass of 750 liters of gasoline? Take the density of gasoline is 680 kg per meter cube. Okay, we have the formula, the mass equal to rho times V, yeah. We have rho here, and then we have V, but the volume is not in SI unit, so we have to convert it to the SI units. 750 liters, we have to convert it to meter cube. Okay, we know that 750 liter equal to decimeter cube, yeah. Decimeter cube to meter cube, move up one step. Here meter cube, here decimeter cube. This one move up one step. It means divided by 1000 or times by 10 power minus 3, yeah. So in here become 750 times 10 power minus 3 meter cube. Okay, and then the mass is equal to the density 680 times 750 times 10 power minus 3. We need calculators. 680 times 750. Okay, divided by 1000 equal to 510 kilogram. Next, number 2. 3 containers having different shapes but equal base areas are filled with the same liquid up to the same height. Okay, same liquid, same height. Okay, compare the pressures and the pressure forces applied by the liquids on the bottom of the containers. Okay, the first, let's compare the pressures. Yeah, the pressure P equal to rho G H. The rho equal, the G equal, the height equal. So the pressure is one container 1, container 2, container 3 will equal, yeah, P1 equal to P2 equal to P3. And then the force is a pressure time area, and then we know the area for their bottom are equal, so the force also equal, yeah, F1 equal to F2 equal to F3. Next, number 3, the cross-sectional area of the two arms of the hydraulic lever are A1 100 cm square and A2 10 cm square, and the mass of the piston here 4 kg. What is the height h in units of centimeter when the system is at rest as shown in the figure? Okay, we try to looking for the h, the height of fluid at the left arm. Okay, first we take 2 points where the pressure are equal. I will take here, yeah, I will using dash line here, point A, and at the same level here, point B, located at the same liquid. And then we know PA equal to PP. Okay, and then when we talk about pressure, we talk about object above the system we observe. Above A, there is pressure from this liquid, yeah, pressure from that liquid, and then pressure from atmosphere, P0. Here also P0. Okay, above point A there is P0 plus rho GH. Okay, equal to above point P there is pressure from this piston. Pressure from that piston is a F piston over area piston plus there is P0. You can cancel directly the P0, P from atmosphere. Rho GH, the fluid here is a water, yeah, where the rho of water 1000 kilogram over meter cube. Okay, and then rho GH equal to the force from piston replaced by the weight. Weight is a mass of piston times G over area piston is area 2, yeah, area 2. We cancel for G, and then the H equal to mass of piston divided by rho area 2. Mass of piston is a 4 kilogram. Rho of water is a 1000. The area in 100 sorry, area 2, yeah, area 2 is a 10 centimeter cube, we have to convert it to meter cube. Centimeter to meter, move up 2 steps. Yeah, 1, 2. But this one square, so divided by 10,000 or times 10 power 4. Okay, 10 power minus 4, I'm sorry. So in here become 10 times 10 power minus 4, become 10 power minus 3. So right here the A2 in meter square is a 10 power minus 3. We cancel, and then the result is 4 meter or 400 centimeter. Number 4, open the mercury barometer is shown in the figure. What is the absolute pressure of the gas in the balloon? If H is a 20 centimeter, okay, atmospheric pressure is 1 atm. Express the answer in A in centimeter Hg and then B in Pascal. Okay, first we take 2 points with the same pressure here at the border, yeah, and here this is point A, this is point B. Above A there is pressure of PA, I will write here is equal to PB. Above point A is a pressure from gas. This is that we looking for. Absolute pressure of the gas, yeah, equal to above the point B there is the pressure from mercury and the pressure from atmosphere. So above it there is P0 plus P from mercury. Then P gas equal to rho GH, rho for mercury plus pressure from pressure gas equal to P0 is 1 atm. Okay, plus rho GH, rho of Hg G times H 1 atm plus rho of mercury, it is 13,600. G is 10, the height is a 20 centimeter. In meter is a 0.2 meter. 1 atm plus this one 2, so 13,600 times 2 is a 00272, 27,200. Okay, and then we change it into centimeter Hg and Pascal. Better we use Pascal first because this one already in Pascal, this one in atm. 1 atm is a 10 power 5 Pascal plus 2 1 2 3 4 1 2 3 4 5 0.27 10 power 5 Pascal. So the result 1.27 10 power 5 Pascal. Okay, and then in centimeter Hg, if 10 power 5 Pascal equal to 76 centimeter Hg, then we have to looking for if 1.27 10 power 5 Pascal equal to X, yeah, X. We can cancel 10 power 5 like that, and then X is equal to 76 times 1.27, yeah, 76 times 1.27, 76.52 centimeter Hg. Okay, for number 5, gasoline is poured into the left arm of a U-tube which already has some mercury in it. When the gasoline column reaches a height of H2 19.4 centimeter, okay, the level difference between the mercury surfaces become H1 equal to 1 centimeter. Okay, what is the density of gasoline? The density of mercury is 13.6 gram per centimeter cube. First, we put 2 points at the same level. Yeah, point A at the border between gasoline and mercury, and then point B at the same level. Okay, and then the characteristic PA equal to PB. Above A there is pressure from this gasoline, PG, and then also there is P from atmosphere, P0, plus above point B there is pressure from mercury, plus also there is atmospheric pressure also, P0. You can directly cancel. P gasoline is equal to PHG. Okay, and then P gasoline is a rho gasoline G, and then H2 equal to rho Hg G H1. Directly we can cancel the G. I will bring here rho gasoline equal to rho Hg mercury times H1 over H2. This one 13.6, H1 is a 1, H2 is a 19.4. Okay, and then the result is 13.6 divided by 19.4. It is 0.7, yeah, 0.7, you round it, gram over centimeter cube. Okay, or it's about 700 kilogram over meter cube. Okay, that's all the explanation for this video. You can like, comment, and share this video, and then don't forget to subscribe my channel and turn on the notification to update other videos from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.